Now it's time to dance. It's groove. It's a band. You like bands that are uncoordinated with crazy music? That's the state of the IT. Crazy. Sometimes it is really, really crazy if you're looking on this orchestration. And with this talk, I want you inspired to rethink your IT and involve you in a motto from the B42, the system is the asset. Who from you is a software developer? You don't think in systems, sorry. Please change your mindset. Think in complete systems that create value. That is the customer pay for. Not for software, they pay for the system to create value. And that you must rethink. And then you got fine music. And what is the purpose of DevOps practices? It is build your system, ship your system, run your system. But you can't do it in a very dynamic space, all with automated, test it, measure it, and then you can change it very easily. If you drop the automatic thing, if you drop the test, if you drop the measure in production, you can't change the system very easily. You must automate that. On the speaker dinner yesterday, we talked about CDD. What CDD is? It's a new token? No, it's cake-driven development. It's birthday parties. Yes, Niklas, from my colleague, want cake-driven developer in 1 year, the biggest birthday party for Docker that ever seen on the planet. He organized that. It's cake-driven development. It's motivating for the cake, for a value, for a great value, I think. And then we can change the world, the IT world, have more fun. For me now, more than 3 years, work with Docker containers. I work for a long way on very scalable systems, now more than 24 years, working in the space of distributed systems and create great sites that really scale. And what I learn is you must motivate your team to do that. Stand up in the morning and say that. Build, ship, run any app anywhere. That is a really important topic for you. Don't write a software piece. Ship a system. At every day, multiple times. That motivates me to create containers and put it together to create on smaller pieces big systems that really scale, create fast value for the customers that I want anywhere on the planet. And what we can do and why it is so easy with Docker, they use the kernel features for virtualization, the isolation and little pieces that are there, that build in the kernel from all these developers on the clouds. Easily you put all your pieces in one little container and don't put a lot of pieces in one container or one machine. Then you cannot combine it on a great value base and have a management layer for every host that you can easily change the system that you have. Use the resources that are really available on your hardware. Don't put layers between your software and the real hardware that don't create value. If you use it, who is from you use Java? I think you use in really a little tiny part of Java and use a lot of frameworks. You don't create really value on the deeper side of Java. You use Spring, and Spring or G2E creates the value for you. You think it creates value, but it needs time. You start your container and it's not available for a minute or so. It don't create value if you restart it. And then you make the decision, let these pieces of software longer running. Oh, longer running, and your businesses change. I think that's not a good story. And what we must build for with containerized technologies, with cloud, is build tiny pieces that people can combine to create new value, and we can change it very easily. And the most things what a container package is, you put your packaging system in the container in an isolated way, and then it consumes memory, CPU, I/O, some network and storage devices. Put some devices in IoT space or configuration to your software, and it is running. But if you overload your container, you must build heavy-wide, specialized transports for that. It's on a standard way, you can easily put your software in it, and it's not so complicated. And it's also not complicated to package the container. If you do it with complicated things, you can't change it. You have not enough time to do that, or you can transfer it to a colleague. Put it in the easy way. The easiest way for Docker, for images, is build a static image, a runtime process, put it in the container, and let it run. Don't have a package system or so. You can build it directly from source in a static binary that your CPU consume it, your kernel. It's easy. Don't put a Java virtual machine between your hardware and your generation of value. That's not a good story anymore. And the Docker ecosystems grow very fast. You can very easily build images, like Roland tells us. You put it in a registry, let it load from an engine on different hosts, or create a swarming mode that you can control a lot of machines with easy packaging format like a Docker Compose file to create stacks of container and let it run on multiple machines. Not only one machine, and you don't say Asterix run the database and Obelix create the microservices. It depends on the situation how a machine is available for your pieces of software. And you must add a layer to provision machines. It's very important that you can easily create and destroy machines. It's not so easy currently. And what Docker can really do for us, or other container formats, it's a really simple packaging mechanism for your software. It's isolate your application dependency to your libraries. You can create a golden image and ship it. It's so easy. You don't ship your software and another guy or make something with that. It's your software, you ship it, you decide what's inside. That's so easy. And then you can debug it easy or understand it easy. You can easily distribute it. Your application can very fast scaling on tiny pieces of containers. It's so simple to test applications in combination now with containers, and you can roll forward very fast your services. The benefits that you have is separation of concerns. You don't put things together that cannot live together, and your developer focus on create systems instead of applications. Your system administrator focus on deployment and delivery. And you can have a better resource virtualization on your host. You have not this virtualization between your software and your running application. Your testing cycle is faster, your portability is faster, your scalability is faster, and create more value for you. And let's dance with orchestration. You see, I remove a lot of guys in this picture. Not a big orchestration. We can create value in small teams and not with so many guys that are useless. And what Docker Swarming do for us, and that is one of the orchestration mechanisms like Kubernetes that Timo talked about that. Another one, a simpler one, I think. It built on top on Docker machines. It's now more than a half-year old. A year old, or not, 9 months or so. And what they do for us, it built a simple control plan. Every Docker engine can be a controller, a manager that saves the state of the complete orchestration environment. And it chooses a leader. The leaders makes a decision on which machine the next container your stack is deployed. And then you have a lot of workers on it that is available for running your containers. Very easy infrastructure, and it's very democratic. You can change the rule of every node. A manager can be a worker, and a worker can be a manager. Think a little bit about this sentence. You can switch the rules. Managers must work. Workers must manage. Okay? And you can do it in technology. It changes your organization a lot. And what you do, or those managers do, makes a decision on which workers the next containers must be running. Maybe choose the service object, create a virtual IP for it with the allocator, schedule it, and make available which node can running the system, and then dispatch these tasks to one of these workers. The worker execution, the description, and the container is started, or a lot of containers of these services status available in parallel on different boxes. It's very easy. By example. The tiny example, you can start it in a browser. Who knows not play with Docker? Nobody? You all have tried out play with Docker. So you can directly build a cluster in a browser, and then you can try all these features. I like these demos. Yeah, what happens on these small devices? You can say, okay, I initialize my swarm and then add my nodes to the swarm leader, or you add new managers to these clusters that is highly available, and then you have built your cluster. If you try out it with Kubernetes, it's not so simple. Yeah, and then you can use it. That's all. You are prepared for clustering now, and you can use it as a service option, and then you can update your service, you can roll forward, you can visualize it, and you can monitor it, and you can load balance it with traffic. An example, it's from Emil, a little Who Am I service. Let's say, okay, hello, what's my IP stack? It's very simple, and use it with a clustered load. You start your traffic load balancer. That's a description for it that can really directly analyze this container that starts on the container and put all these containers directly to the load balancer, and it's available on one thing. So you can automatically create Let's Encrypt certificates and so on, very automatically. You only must start the container. You start the container, you must label it. You can label it with traffic, backend, load balancers, turn traffic, and then you promote your services on the internet. You can scale it, add a replicate to it, to 2, to 10, to 1,000. Last days at promote an article that starts on 3 nodes, thousands of containers. On 3 nodes, thousands of containers in 10 minutes. Yeah, and then you can start a global service. You add a service to every node. If a node comes on top on the cluster, these containers are directly available on this node. And that is cAdvisor, a matrix for your containers, and you want started on every node on your cluster. You must have it available. You must have a resource, memory, CPU, I/O, and so matrix from every machine. And you can roll up. Here's a UI service. It's written in Java as Tomcat. I'm a Tomcat committer, and do something in Java. If you spend more time, and then you see your size of your image can shrink. Dieter has made an example, and now the smallest image is 68 bytes. It's very tiny, and say hello word. You can push it very easily in your cluster. If you do it in this way with Tomcat and Java, you need 120 megabytes for that. Hello world. Yeah, but what I do is build these things, tag it, push it to my local registry, create these UUID service, publish this to a port, replicate it, and then I can update this, build it again with a new version on it, push it, and make a service update, and all containers are restarted on the new image. That's really easy to scale and orchestrate services. Yeah, access it is very easily, like the UMI service as an index, and then you create a new UUID. Then you can visualize it. It's a small project from Nanomarks. And then you can see very easily on the picture how the container starts, restarted, is it available or not on the complete cluster. It's a tiny visualization for that, but it feels right as developer to see that your system really working well on different machines. It's not only built for production, it's built for you as developer. To see your system, it really works, the mechanism works like a system, something you can put a part of you, drop it, destroy it, and see it directly what happens. Is your application really resilient or not? Yeah, and you add one, you see it directly. You can start more on Matrix. You can have Matrix on your node, on your cAdvisor very easily, or start Prometheus to grab all matrixing from all boards. Has these DNS configuration here. You can see, okay, every task, every container is promoted to the DNS server from the Docker engine, and then you can grab automatically containers in this DNS group. It's really, really easy and fast to build those Prometheus things in the Docker cluster or in a Kubernetes way. Very automatic. You can add label to structure your machines to say, okay, or you make a difference on big machines with CPU and memory and other machines that have really big storage or fast storage to deploy your container and services to the right machines that can run your services. Handling persistence is currently a problem. We have only mounted name value, anonymous values are directly host values. If you want to write to a clustered file system, then you need a driver plugin and promote it to all your machines before you can use it. That's not seems good. But for stateless services, it works very well. More Docker Swarm possible, yes, try it out. Ask me, ask other guys in the room, come to the open space, and then we can try it really out in practical. Is it really heavy to start it on one single node? No. You can swarm your node, you analyze it, and then you start a small number of Docker container for that, and promote it as a cluster. Then you can simulate machines on one machine. You can create your cluster on one machine. It's very easily. I have set up a project for a meetup, Traffic with Docker, and maintain that now to have smaller start scripts and so, and document those experiments that you can have a fast development on your machine, on your laptop, that simulate a complete cluster, and it's working very well. It's set ups in seconds, not minutes. What is the new projects on the Docker orchestration or orchestration space to create now machines? A deeper level, not your software, you create an orchestrator for machines. That is the reason behind the InfraKit project from Docker. And hacking around and start machines if you need it in an availability zone around the globe. You can spin out machines, not only in your data center, you spin out it in the cloud and make a bigger cluster around the globe of your software available, or start it on-premise in your data center to make it easier to scale out and scale down your machines for use your environment. And it is a declarative management. It has an active control to monitoring your infrastructure, detecting state divergences and taking into action. It has continuous monitoring and considering, and it's a rolling update. You can update your machine. And what we do is an architecture built like the Docker Swarm mode to have a control plan, some leaders on it, and we make a decision to pads and cattles. You know the difference. Pads has state and cattles not, stateless, and have different mechanism to handle those machines that works on a cattle or works on a pad, and make a difference to handle it. If you handle a pad, you cannot drop the machine very easily. You must be clever and back up the data before you drop the machine and start it on another machine, or make it possible for you to have a database that has a replication mechanism inside the software. But believe me, it's not so easy to create good software in containers. My golden rules are, say, okay, if you put a software in a container that have a clear purpose, one purpose. If you look on the Docker Hub, you see a lot of images that have different purposes. If you bundle an Nginx or an HTTP Apache server, then you can promote different configuration for that, and that have very, very different purpose. You can handle it as proxy, you can handle it as a PHP environment, as a Ruby environment, whatever you do, and you look like in this software, then you see all modules are loaded. We are on JData currently, and I hope you know the risks, the security risks, if you include all these modules in one binary. The attacker is not your friend. And the other thing is label your container. Say, okay, it is for some purpose, there's a maintainer on it, or it's working like a service, a backend or a front end, whatever you want. There exists a lot of labeling standards now in the container scene working with that. And make sure that your software really working. Have you started a container that don't work? Yes, I have do that. I crashed. Or have a clear documentation how you get running this piece of software. And fix the dependencies on your software. Don't include new ones. Have a minimal container. Don't include many useless data in that, an option or so. Let the consumer choose that. Have a white box, make your software, the resources available, make it available and update this periodical. Make a test with limited resources. Don't say, okay, a normal container consumes the complete resources from the machine, make some test. You can limit that. It's easy to scale it. If you can limit it, then can you say, okay, this software consumes a gigabyte of RAM, and you have hundreds of megabytes on your machines, and you can run these containers hundreds of times. If you choose it needs 50 gigabytes of RAM, then you can choose 2 or 1. And trust your container. Build trust. And trust is not easy to build. If you're a curator, sign your images. It's so easy with Notary. What we built on the B42 is that we have a blueprint that you create environments for different projects and combine that and deliver orchestration, build pipelines that Niklas showed us yesterday on these workshops, and create security and maintainability of software, and have a good choice of monitoring to create all this measurement directly out of production. Testing is not enough. The real production, and sometimes very crazy. You need more measurement on that. What we do is we're working on this to identify different problems and options for the architectures of orchestrate software. We detect that we need some pipelining our builds. We now control with GitLab or Jenkins, and we are in the matrix space, currently working with Prometheus, OpenSipkin, and Logstash, and AlkStax, and Graylog, and all these things. But we want to build a very clever container for that, open source softwares. And the summary of my talk is, containerize your software, create fast value. Believe me, it creates really fast value if you can use these paradigms. And deploy and run software with Docker swarming is now much easier than ever seen in Orchestrator before. And I'm working on this space more than 20 years. It's so easy to orchestrate software with these software. Learn more about dynamic infrastructure. Use swarming as first, and then learn more complex environments. Please use cloud technologies to create machines that you can scale very easily. Don't use and ask your operator by a Newman. That needs a lot of time, weeks or so. If you create it in a cloud, you need a minute. DevOps, change your organization structure. Do it first. Don't say, okay, I'm working on technologies and it's very useful. Ask your boss, you can change your organization. It changed your complete organization. It's hardcore IT knowledge needed for you. If one of you want a new job, ask me. We need it. And what we do in the B42, we start an aggressive learning culture. We learn every day and discuss what we learn. And it's a good way or not. And it's a very important topic. This learning thing is the thing that motivates you to do new things. Yeah, and the ecosystem moving fast. If you're learning some days not, Saturday and Sunday, then other guys have learned in these days new things. And that can be really crazy for you. It's moving so fast forward that a day without learning, it's hard. Don't forget, reduce the coupling. Design add matrix and use feedback. Design it for failure. Set up your machine and networks automatically. Don't do it manually. Your developer need prod-like environments and good machines, and back up your persistence data. The last topic is very important on the container space. Please back up your data. You can lose it really very, very easily. And the system is the asset. Not your software, it's the system. And the system is not the IT system, it's the complete system. Your organization stuff, your purpose, and your IT. It's a combination. And build your system for friends. That's really important. That is cake-driven development. It's fun. You build it for openness, to make a present for a friend. Your system must like and build for friends. Yeah, many thanks for that. All these slides are shipped in the container. And now I deliver that. Yes. And yeah, DevOps camps, you can go to us to learn more. B42 solution, with B42 we offer jobs. You can go to us for DevOps engineer or want to be a DevOps engineer or you're a web engineer, you're very welcome. Or you go to my other company, Setlog, to a CTO, we also offer jobs. Or you want to buy a book, I have made a translation for Adrian. And if you have interesting questions, then I can give you a book, one book, for a really interesting question. Yeah. Now it's time for you for interesting questions.